Hello everyone, and thanks for watching Edupedia Word video. In this chapter we are going to talk about elasticity. For that, we are going to analyze the price elasticity of demand in section 1. In part 2, we are going to talk about the measuring of the price elasticity of demand. After that, we are going to interpret the figure for elasticity. In section 4, we are going to find out the determinants of price elasticity of demand. And by the end, we are going to talk about the price elasticity of demand and consumer expenditure. The remaining portion related to elasticity will be explained in the next video. So let's get started. When the price of a good rises, the quantity demanded will fall. That much is fairly obvious. But in most cases, we will want to know more than this. We will want to know by just how much the quantity demanded will fall. In other words, we will want to know how responsive demand is to a rise in price. Take the case of two products, oil and cabbages. In the case of oil, a rise in price is likely to result in a relatively small fall in the quantity demanded. If people want to continue driving, they have to pay the higher prices for fuel. A few may turn to riding bicycles, and some people may try to make fewer journeys. But for most people, a rise in the price of petrol and diesel will make little difference in the short term to how much they use their cars. In the case of cabbages, however, a rise in price may lead to a substantial fall in the quantity demanded. The reason is that there are alternative vegetables that people can buy. Many people, when buying vegetables, are very conscious of their prices and will buy whatever is reasonably priced. We call the responsiveness of demand to a change in price the price elasticity of demand. And as we shall see on many occasions throughout this course, it is one of the most important concepts in economics. For example, if we know the price elasticity of demand for a product, we can predict the effect on price and quantity of a shift in the supply curve for that product. This figure shows the effect of a shift in supply with two quite different demand curves. Curve D' is more elastic than curve D over any given price range. In other words, for any given change in price, there will be a larger change in quantity demanded along curve D' than along curve D. Assume that initially the supply curve is S1 and that it intersects with both demand curves at point A at a price of P1 and a quantity of Q1. Now, supply shifts to S2. What will happen to price and quantity? In the case of the less elastic demand curve D, there is a relatively large rise in price to P2 and a relatively small fall in quantity to Q2. Equilibrium is at point B. In the case of the more elastic demand curve D', however, there is only a relatively small rise in price to P3, but a largely fall in quantity to Q3. Equilibrium is at point C. Measuring the price elasticity of demand. What we want to compare is the size of the change in quantity demanded with the size of the change in price. But since price and quantity are measured in different units, the only sensible way we can do this is to use percentage or proportionate changes. This gives us the following formula for the price elasticity of demand. P epsilon D for a product, percentage change in quantity demanded divided by the percentage change in price. Putting this in symbols gives this formula. P epsilon D equals the percentage delta QD divided by delta P, where epsilon, the Greek epsilon, is the symbol we use for elasticity, and delta, the capital Greek delta, is the symbol we use for a change in. Thus, if a 40% rise in the price of oil caused the quantity demanded to fall by a mere 10%, the price elasticity of oil over this range will be minus 10% divided by 40%, and that equals 0.25 minus. Whereas, if a 5% fall in the price of cabbages caused a 50% rise in the quantity demanded, the price elasticity of demand for cabbages over this range would be 15% divided by minus 5% equals minus 3. Cabbages have a more elastic demand than oil, and this is shown by the figures. But just what do these two figures show? What is the significance of minus 0.25 and minus 3? Let's interpret the figure of our elasticity before that. The use of proportionate or percentage measures. Indeed, elasticity is measured in proportionate or percentage terms for the following reasons. 1. It allows comparison of changes in two qualitatively different things, which are thus measured in two different types of unit. That is, it allows comparison of quantity changes with monetary changes. The second reason, it is the only possible and sensible way of deciding how big a change in price or quantity is. Take a simple example. An item goes up in price by €1. Is this a big increase or a small increase? We can answer this only if we know what the original price was. If a can of beans goes up in price by €1, that is a huge price increase. If, however, the price of the house goes up by €1, that is a tiny price increase. In other words, it is the percentage or proportionate increase in price that determines how big a price rise is. Now, the sign, whether positive or negative. Demand curves are generally downward sloping. This means that price and quantity change in opposite directions. A rise in price, a positive figure, will cause a fall in the quantity demanded, a negative figure. Similarly, a fall in price will cause a rise in the quantity demanded. Thus, when working out price elasticity of demand, we either divide a negative figure by a positive figure or a positive figure by a negative one. Either way, we end up with a negative figure. The value greater or less than 1. If we now ignore the negative sign and just concentrate on the value of the figure, this tells us whether demand is elastic or inelastic. Case 1, elastic, epsilon is greater than 1. This is where a change in price causes a proportionately larger change in the quantity demanded. In this case, the value of elasticity will be greater than 1, since we are dividing a larger figure by a smaller figure. Case 2, inelastic demand. Epsilon is less than 1. This is where a change in a price causes a proportionately smaller change in the quantity demanded. In this case, elasticity will be less than 1, since we are dividing a smaller figure by a larger figure. Case number 3, unit elastic demand. Epsilon equals 1. This occurs where price and quantity demanded change by the same proportion. This will give an elasticity equal to 1, since we are dividing a figure by itself. Now let's talk about the determinants of price elasticity of demand. The price elasticity of demand varies enormously from one product to another. For example, the demand for a holiday in a given resort typically has a price elasticity greater than 5, whereas the demand for elasticity has a price elasticity less than 0.5, ignoring the negative signs. But why do some products have a highly elastic demand, whereas others have a highly inelastic demand? What determines price elasticity of demand? The answers are as follows. The number and closeness of substitute goods. This is the most important determinant. The more substitutes there are for a good and the closer they are, the more people will switch to these alternatives when the price of the good rises. The greater, therefore, will be the price elasticity of demand. Returning to our examples of oil and cabbages, there is no close substitute for oil and thus demand is relatively inelastic. There are plenty of alternatives to cabbages, however, and thus demand is relatively elastic. The proportion of income spent on the good. The higher the proportion of our income we spend on a good, the more we will be forced to cut consumption when its price rises. The bigger will be the income effect, and the more elastic will be the demand. Thus, salt has a very low price elasticity of demand. Part of the reason is that there is no close substitute, but part is that we spend such a tiny fraction of our income on salt that we would find little difficulty in paying a relatively large percentage increase in its price. The income effect of the price rise would be very small. By contrast, there will be a much bigger income effect when a major item of expenditure rises in price. For example, if mortgage interest rates rise, that means the price of loans for house purchase, people may have to cut down substantially on their demand for housing, being forced to buy somewhere much smaller and cheaper or to live in rented accommodation. Now let's talk about the time period. And here, let me say that when price rises, people may take time to adjust their consumption patterns and find alternatives. The longer the time period after a price change, the more elastic the demand is likely to be. To illustrate this, let us return to our example of oil. Indeed, between December 1973 and June 1974, the price of crude oil quadrupled, which led to large increases in the prices of petrol and central heating oil. Over the next few months, there was only a very small reduction in the consumption of oil products. Demand was highly inelastic. The reason was that people still wanted to drive their cars and heat their houses. Over time, however, as the higher oil prices persisted, new fuel-efficient cars were developed and many people switched to smaller cars or moved closer to their work. Similarly, people switched to gas or solid fuel central heating and spent more money insulating their houses to save on fuel bills. Demand was thus much more elastic in the long run. In 2007 and 2008, oil prices again were increasing very sharply. If the high oil price has persisted, we might have expected to see patterns of demand changing over the next few years as consumers adjusted to these higher prices. In fact, within months there were signs of these effects beginning to occur as demand for large fuel-hungry cars in the United States, such as Hummers and other cars, fell and demand for smaller European and Japanese models rose. But as recession swept the world, so the oil price rapidly fell. We would have to wait for recovery to see soaring oil prices again. Very good. Now let's talk about the price elasticity of demand and consumer expenditure. One of the most important applications of price elasticity of demand concerns its relationship with the total amount of money consumers spend on a product. Total consumer expenditure is simply price multiplied by quantity purchased. For example, if consumers buy 3 million units at a price of €2 per unit, there will be spent a total of 6 million euros. Total consumer expenditure will be the same as the total revenue received by firms from the sale of the product before any taxes or other deductions. What will happen to consumer expenditure and hence firms' revenue if there is a change in price? The answer depends on the price elasticity of demand. Elastic demand. As price rises, the quantity demanded falls and vice versa. When demand is elastic, quantity demanded changes proportionately more than price. Thus, the change in quantity has a bigger effect on total consumer expenditure than does the change in price. For example, when the price rises, there will be such a large fall in consumer demand that less will be spent than before. This can be summarized as follows. P rises, Q falls proportionately more. Thus, the total consumer expenditure falls. When P falls, the quantity rises proportionately more. Thus, the total consumer expenditure rises. In other words, total expenditure changes in the same direction as quantity. This is illustrated in this figure. The areas of the rectangles in the diagram represent total expenditure. Why? The area of a rectangle is its height multiplied by its length. In this case, this is price multiplied by quantity bought, which is total expenditure. Demand is elastic between points A and B. A rise in price from €4 to €5 causes a proportionately larger fall in quantity demanded, from 20 million to 10 million. Total expenditure falls from 80 million euros, the stripped area, to 50 million euros, the pink area. When demand is elastic, then a rise in price will cause a fall in total consumer expenditure, and thus a fall in the total revenue that firms selling the product receive. A reduction in price, however, will result in consumers spending more, and hence firms earning more. Now, let's talk about the inelastic demand. And here, when demand is inelastic, it is the other way round. Price changes proportionately more than quantity. Thus, the change in price has a bigger effect on total consumer expenditure than does the change in quantity. To summarize the effect, when P rises, the quantity falls proportionately less, and total expenditure rises. When the price falls, the quantity rises proportionately less, making the total consumer expenditure falling. In other words, total consumer expenditure changes in the same direction as price. This is illustrated in this figure. Demand is inelastic between points A and C. A rise in price from €4 to €8 causes a proportionately smaller fall in quantity demanded, from 20 million to 15 million. Total expenditure rises from 18 million euros to 120 million euros, the pink area. In this case, firms' revenue will increase if there is a rise in price and fall if there is a fall in price. Now we are going to talk about some special cases This figure shows three special cases. A totally inelastic demand, P epsilon D equals 0. B, an infinitely elastic demand, P epsilon D equals infinity, and C is a unit elastic demand. Totally inelastic demand. This is shown by a vertical straight line. No matter what happens to price, quantity demanded remains the same. It is obvious that the more the price rises, the bigger will be the level of consumer expenditure. Infinitely elastic demand. This is shown by a horizontal straight line. At any price above P1, demand is 0, but at P1 or any price below, demand is infinitely large. This seemingly unlikely demand curve is in fact relatively common for an individual producer. In a perfect market, as we have seen, firms are small relative to the whole market, like the small-scale grain farmer. They have to accept the price as given by supply and demand in the whole market, but at that price they can sell as much as they produce. Demand is not literally infinite, but as far as the firm is concerned, it is. In this case, the more the individual firm produces, the more revenue will be earned. In this figure, more revenue is earned at Q2 than Q1. Finally, let's talk about the unit elastic demand. The last curve. This is where price and quantity change in exactly the same proportion. Any rise in price will be exactly offset by a fall in quantity, leaving total consumer expenditure unchanged. In this figure, the stripped area is exactly equal to the pink area. In both cases, total expenditure is 800 euros. You might have thought that a demand curve with unit elasticity would be straight line at 45 degrees to the axis. Instead, it is a curve called a rectangular hyperbola. The reason for its shape is that the proportionate rise in quantity must equal the proportionate fall in price, and vice versa. As we move down the demand curve, in order for the proportionate change in both price and quantity to remain constant, there must be a bigger and bigger absolute rise in quantity and a smaller absolute fall in price. For example, a rise in quantity from 200 to 400 is the same proportionate changes as a rise from 100 to 200, but its absolute size is double. And a fall in price from 5 euro to 2.50 euros is the same percentage as a fall from 10 euros to 5 euros, but its absolute size is only half. Very good. This is the end of this video. As I said, the remaining portion will be explained in the next video. So, thank you very much for your attention.